let's see if we can have that diagram drawn. This is a center point. This ought to just touch. Ought to just touch. This is 72. This is 72 degrees. And we're not told what this angle should be. And we're told that the center O is given to us. So, as is a practice, we'll try to name the figure. So I'll call here, let's say I'll call here A. I'll call here T. I'll call here B, small letter B. So I'll say using notation as a diagram. We are told to look for alpha. Now, we are now into tangents. We said that the tangent is a straight line that touches the circumference of the circle while creating a perpendicular relationship with what? The radius. So this is the radius. Anytime you see that in any diagram, it means that this angle must be what? 90 degrees. So you say that B is equal to 90 degrees. What is the reason for that? Radius perpendicular. That sign means what? Perpendicular to what? Tangent. So the radius perpendicular to tangent will create the fact that this angle will be what? 90 degrees. Alright, so B is equal to 90 degrees. What's the reason? The radius is perpendicular to the tangent. Now, we cannot look for alpha. Alpha plus B plus 90 will be equal to 180 degrees. What's the reason for that? You discover that OAT is a triangle. So we'll say what? Angle sum of what? Triangle. So with that settled, I know what B is. So I'll say what? Where am I getting 90 from? 72. I was wondering. So this will be alpha plus 90 plus 72 equal to 180. So I have that alpha will be equal to what? 180 minus 162. So invariably, alpha will be equal to what? 18 degrees. Alright. So that's what that problem will be. Now, when you solve a question like this, the first thing is to try to label the diagram. So I could call here A, I'll call here B, and I'll call here T. Now, I'll use letters. Let me call here a small letter A, and let me call here a small letter B. So the first thing I'll tell my examiner is that what? Using notations. As in diagram. Using the notations as in diagram, I can find A. What will A be equal to? 90 degrees. And what's the reason for that? The radius is perpendicular. That's the symbol for it. Radius is perpendicular to what? The tangent. Now, we know this is 90 degrees. So what is B? How do you know it's 45? It's not. Look at this angle here. Look at this angle here. If this is alpha, and this angle here is 90 degrees, did I do that thing right? No, I didn't do that thing right. There's an error to that. I'm surprised we didn't notice it. I didn't do that thing right. This is A, this is B, and let me call here C. I didn't do it right. We're not observant. I didn't do it right. Now watch. C plus alpha is equal to 90 degrees. C plus alpha is equal to 90 degrees. What's the reason for that? Radius perpendicular to tangent. This is not where you have the tangent. This is where you have the tangent. Tangent and then length. So if C is equal to alpha, and C plus alpha is equal to 90, it will mean that what? C must be equal to 90 minus alpha. Is that not? Is that not? Beautiful. So with that settled, let's watch something else that's very interesting and instructive for you here. I hope you know that this will be equal to this. Why? OA is equal to OB. What's the reason for that? Radii. So if that is true, it means that triangle AOB is what? Isos. So it will also mean that B is equal to C. Why is B equal to C? Alternate angles. Beautiful. Alternate angles. TB parallel to what? AO. The alternate angles, this and this are equal. So we have a situation where watch. We have a situation where B is equal to alpha, base angles of isosceles triangle. B is equal to alpha. Because what? They are what? Base angles of what? Isosceles triangle. Okay, with that settled, it will be in the words that B is what? Equal to C and it's equal to 90 minus alpha. So 90 minus alpha will be equal to alpha. Is that not? So it will follow that what? 90 must be equal to alpha plus alpha. So alpha, 2 alpha will be equal to 90 and alpha will be equal to 90 divided by 2, which is what? 45 degrees. Now, what we're told to look for was what? Alpha. Is that not? So we've solved it. Now, I know some of us would have said that, but we're getting the same A as 90. That was an assumption. It wasn't based on any deductive reasoning. Anything you do here must be based on deductive reasoning drawn from the theorem. That's why I had to take you through. You discover that the ideas keep connecting themselves. So if you've not taken care to observe what you were taught in your SS1, by the time you come to your SS2, where you will now be applying those ideas, some of these things will appear confusing. Right, so that settles that problem and we are done with that. Okay, so we look at this one. This is also very easy. I'm going to call here A. And I think we just had lecture. We would be good in solving this. So I'll say using notations as in diagram. So if I say that, it means that A must be equal to 90 degrees. The reason is what? Radius perpendicular to tangent. Radius perpendicular to tangent. Radius is perpendicular to the tangent. So alpha plus A plus 27 will be equal to 180 degrees. This obviously is a triangle. So it will be angle sum of triangle. Angle sum of triangles. So alpha plus 90 plus 27 will be equal to 180 degrees. Is that not? Is that not? Alright, so alpha will then be equal to, let's take it gradually, plus 117 equal to 180 degrees. You can actually use your calculator to process from here. Now, once you've stated this, and you're able to state this, you've done, that's enough for method. The next thing the examiner wants to see now is this. So alpha rather, will be equal to 180 minus 117, which will be what? 67, is that? 67, is that not? 3. Okay, 63. Alright, that will be 63 alpha will be equal to 63 degrees, and that settles that question. So we're done with that, and then we can move on.